All right. Hello. Thanks for coming to this session. My name is Miao Jiang. I work on the Azure API Management team. So in this session today, I'm going to show you how you can manage your microservices-based APIs using API management. So before we start, just a few words about microservices. So we all know that in the last few years, organizations are increasingly adopting the microservice architecture to become more agile and to keep up with the changing customer needs, right? So in the traditional software development model, applications are built and shipped in monolithic blocks of tightly coupled code, right? In contrast, in a microservice architecture, there is a network of small autonomous services, and each individual service implements a single business functionality and is self-contained, right? As a result, there are a number of benefits of this architecture style, such as independent development and deployment, freedom to choose technology for individual services, easy to understand because each service just implements a single functionality, right? And also you can scale individual services independently, and those services are also highly reusable and resilient. However, everything comes with a price, right? There are also a number of challenges of this architectural style. So to me, the two main challenges are, first, how do you manage the communication between the services within an application, right? Because we all know that for an application to work, those services need to talk to each other. However, with a growing network of microservices, how do you manage the service-to-service communication, right? Because as developers, we only want to focus on the business logic. We don't want to worry about how my service interacts with another service. So for this challenge, organizations are increasingly adopting a service mesh, such as the open source project Istio. And we're not going to dive into this challenge today, because the challenge I want to focus on today is how do you manage the communication between your application and the consumers of your application, right? So the answer to this question is consumers should be communicating with your application via APIs through an API gateway. So there are 2 points here. First of all, you need to publish your microservices as APIs, right? And second, when you do that, you need to publish them with an API gateway. So why do you need an API gateway, right? What are the benefits of using an API gateway with your microservices? So first of all, API gateway serves as a reverse proxy sitting in front of all your microservices serving incoming requests to the backend services, right? This allows you to put all your microservices behind a single domain name, right? But more importantly, this decouples your front-end apps from your back-end microservices and makes it a lot easier for you to evolve and refactor your services on the back-end, right? And also, if you are just starting to migrate to microservices, you can put an API gateway in front of your existing monolithic systems while you gradually split them into microservices. And these changes will be transparent to the front-end apps. They don't even know that you have migrated or if you are migrating to microservices. And also, since all the traffic goes through your API gateway, it gives you a single point of control of all the traffic that goes to the backend from all the front-end apps, right? And the second benefit of using an API gateway is that since it sits in front of your services, you can have all the cross-cutting concerns in the API gateway, right? For example, authentication, authorization, throttling, and caching, right? You can also leverage the gateway to do response transformation to accommodate different needs of different apps, right? For example, your mobile app might want a different format than a web app, right? And with the API gateway taking care of all the cross-cutting concerns, you don't have to worry about them in your microservices, and this is helpful in keeping your microservices simple and clean, right? And last but not the least, with an API gateway, you can also use it to do request orchestration, right? Basically, the front-end app can send a single request to your API gateway, which will then dispatch multiple requests to the backend services, aggregate all the responses from the backend, and send a single response to your front-end app, right? This is helpful in reducing the chattiness between the front-end app and your backend services, and ultimately helps you to reduce network latency and improve the responsiveness of your apps. So for those of you who are familiar with our current offering of API management, you know that we currently provide a powerful API gateway in our offering that you can use together with your microservices in these scenarios, right? However, over the last couple of years, some of our customers have mentioned to us that in addition to our current offering, they would like to see a lightweight, pay-per-action offering of API management. And many of them are willing to trade some functionalities for this new pricing model because they have very simple use cases, right? For example, they might just be looking for a lightweight API gateway in front of their Azure Functions, right? So we heard of those feedback, we thought about it, and we took action. So today, as a result, today at Ignite, actually literally less than 30 minutes ago, we just announced a new pricing tier of API management, tentatively called consumption. So this is a new tier of API management. The primary use case of it is to provide an API management layer for your microservice-based architectures, right? It comes with certain serverless properties, such as instant provisioning, automated scaling out and back to zero when there is no traffic, right? Built-in high availability, and most importantly, per action pricing, meaning we will be charging you based on the number of API calls. So if there's no API call, there's no charge, right? And as mentioned before, this new offering will have a curated feature set. For example, there will be no developer portal, no out-of-the-box cache, but you can bring your own cache. And it will have certain usage limits, such as number of APIs and execution time. So some of you might find this new offering more desirable in some of your use cases because of its pricing or because of its serverless properties. So in the next 15 minutes of my session, I'm going to show you how you can expose your microservices using API management. And throughout my demo, I will be using this new consumption tier to kind of show you how it works. So today, we all know that in Azure, we have a number of awesome services to help us implement and host our microservices, right? Such as Azure Functions, Service Fabric, Azure Kubernetes Service, AKS, or Azure Container Instance, ACI, right? So in the interest of time, today I'm going to focus on two of them, Azure Functions and AKS. So how do you expose your Azure Functions with API management? Here is how the mapping looks like. So if I'm building a service using Azure Functions, some people prefer to use a single function app with multiple functions inside it, each representing one resource, right, in your application, such as order or product. And each of those functions will support one or more HTTP verbs depending on your needs, right? And then you can map this function app as an API in my API management instance with multiple operations. That depends on the number of functions you have in your function app and the number of HTTP verbs, right? So in my example here, my function app is mapped to 3 operations in my API, which is get order, post order, and get product, right? And the communication or the connection between the API management gateway and the function app will be secured by the function key, and your function app will be exposed as APIs through the API gateway. And then for some other people, they would prefer to use multiple function apps for different resources. For example, if they want to set deployment boundaries between different resources, right? That's totally fine. That's purely personal preference and doesn't really matter. If you use multiple function apps, you can still map them into a single API in API management. So let's take a look at how this works in action, right? Let me exit my presentation, switch to my browser. So let's pretend that I am running a small online business that sells, superhero gadgets, right? Like, Superman's cape or Batman's mask, right? So for my little business, I have used function app to implement two services called coupons and products, right? Basically, it allows applications to get the list of current available coupons and the list of product that I sell, right? So let's say I have tested my function app, everything looks good, right? I am ready to expose it using my API management instance. So let me switch to my API management service. So for those of you who are not familiar with API management, this is the management user interface for your API management service. And as you can see under tier here, it says consumption, just to prove that I'm using the new consumption tier. So to add a new API into API management, I will go to the APIs view. So this is the user interface for you to manage all your API facades in API management. And as you can see, to add a new API, we support many options. Like you can import Open API specification, WADL, or WSDL. And for apps running on Azure, we really want to make sure the experience is very simple. We want to make sure first-class support, right? So to import a function app, I can just click on this tile called function app and browse to my function app. Which is this one. And then it will show me all the functions under this function app. if the network works, yep. So I can choose to expose all my functions, or I can choose to expose only a subset of my function app, right? Let's say I want to expose all of them. Select. I hope network is cooperating. Normally, it shouldn't take that long. Let me try to disable Wi-Fi, because I'm actually on cable. Let me refresh this page just to make sure. Yeah, I think that the cable is not working, so let me try to use the Wi-Fi.
Here's the,
okay.
This is the demo Wi-Fi.
Try the demo Wi-Fi. Sorry about that. Okay, let's try that again. I'm going to import this function app, browse it to my function, API demo, select all of them. Okay, this item is working. Let's give it a nicer name. Let's call it Superstore, because I'm selling superhero stuff. Okay, so now you can see a new API has been added to my API management instance with two operations, which represent the two functions under my function app, right? So what really happened behind the scene is that API management called the function app API to get all the metadata about my function app and use the metadata to create the APIs and operations in my API management instance. And in addition to that, we also created a function host key and saved it securely in API management so that we will use this key when we call your functions, okay? So everything looks good. Let's give it a try to see if everything works. So we have a test console embedded here in the management experience so that we can try our APIs without leaving this UI. Let's try the products operation. And there you go, I just got a list of the products that I sell, right? So now my function app is protected by my API management instance and enjoy all the benefits of the API gateway. This is how easy you can expose your function apps using API management. I literally, without the Wi-Fi issue, it just took me a couple of minutes, right? So next, I'm going to show you how you can expose your services running in Azure Kubernetes service using API management. So here is how the architecture looks like. Basically, in your Kubernetes cluster, you will have a swarm of pods running your containers, right? And then you will use the service object in Kubernetes to front these pods, because pods kind of come and go. They don't have a reliable IP address, right? You can use the service object, which provides you a reliable IP address. And then you can map these services into one or more APIs in API management. But the question here is, if my API management instance does not run inside the same virtual network as my Kubernetes cluster, how do I secure the connection between the two, right? It's very simple. What you can do is you can install an ingress controller in your Kubernetes cluster, which supports mutual certificate authentication, and then API management gateway will be using certificates when communicating with your cluster. Alternatively, if you prefer to keep your cluster completely private inside the virtual network, right? If you don't want to have any public endpoints of your cluster. So what you can do is that you can deploy your API management instance in the virtual network as well, so that API Management Gateway becomes the single interface between outside of the virtual network and inside of the network. And everything has to go through the API Management Gateway, right? And then between the gateway and your cluster, since it's within the virtual network, so it's secured, and we will be communicating with internal IP addresses, right? So you don't have to use the ingress controller or certificates anymore. Just a reminder that the virtual network deployment option is only available in our premium tier if that's something you want to, if this is the topology you prefer. So in my demo today, I'm going to show you the first option, which means the API gateway will be communicating with the cluster over the internet using certificates, okay? So let me show you my Kubernetes cluster first. Let me switch to my VS Code. So let's say for my little online business, I have implemented in a containerized order processing service, which will process incoming orders, right? And I have deployed my service into an AKS cluster. So I have a terminal running here in my VS Code. So if I do kube control get pods, you will see I have a pod named order management service running my container in a cluster, right? And if I do kube control get services, you will see I have a service object running in my cluster, which is managing my pods and forwarding requests to my pods, right? And for this service object, it has an internal IP address because I am not exposing it directly to the internet. I'm using an ingress controller, right? So if I control get ingress, you will see this is my ingress. It has a host name, right? This is what people communicate. This is how people communicate with my cluster. So as I mentioned, in my ingress controller, I have enabled TLS client certificate authentication, right? So just to show you that these are my ingress rules. And here you can see I have enabled, TLS verify client certificate. It's on. And below here is the URL mapping from incoming request to my backend services. So now I also have a REST client right here in my VS Code, right? If I try to call my cluster, what will happen? Any takers? It will fail, right? Because I am not using a certificate. So let's give it a try. So I immediately get a 400 bad request because no required SSL certificate was sent, right? So at this point, my cluster looks good, my pods are running, my services are running, my ingress controller is running, and the authentication is working, right? So I'm ready to expose this order management service through my API management instance as well, right? So let me switch back to my browser. So for this order management service, I have created a Swagger file or open API specification for it. So this is how it looks like. Basically, it contains all the metadata about my service. As you can see, it's called Order API, and this is a host name, and it has one operation called post order, right? So if I copy this link here, go back to my API management instance, and I can add a new operation into my existing API by clicking on the three dots here, say, okay, import. This time we are going to use the open API specification. Let me paste the link. And we will use the append mode since we are adding new operation. We don't want to overwrite anything. Okay? And import. Okay, so now in addition to the two operations we imported from function, now I have another operation called post order, which is from that Kubernetes cluster. So if we try to give it a call, what will happen, right? It will fail again. Let's try it. Because API Management Gateway doesn't know that it needs to provide a certificate when calling this backend. So all we need to do now is to add a policy in the gateway to tell it to apply a certificate when calling this backend. So before this demo, I have already uploaded a certificate to this API Management instance. It's right here. So let me just copy the thumbprint of this certificate, go back to my API's view. So for this operation, I want to add a policy right here. Right here. So the policy is called authenticate with certificate, right? So let me just paste in the thumbprint of that certificate so the gateway knows which one to use, right? And save it. Okay, so now if I go back to the test console, try to give it another call, let me get a payload for this order. Okay. So now you can see the backend says order has been accepted, right? This is how easy you can import your services running AKS through API management as well. So now both my services running in functions and AKS are secured and managed by my API management gateway and enjoy all the benefits of the gateway. So, as you have seen in this demo, throughout this demo, I've been using this new consumption tier of API management. We are starting the private preview of new tier very soon. So if you're interested in trying it out and give us feedback, please go to aka.ms/APIM preview. We have very limited seats for preview, so please try to apply as early as possible. And here are a few more links that are helpful to you, but don't worry, you will get the slide deck from the Ignite website, so you don't have to write them down. And last but not the least, please submit your evaluation for this session, because someone's bonus depends on it. I'm just kidding. Thank you.